Okay, we've got this pump connected to a generator operating at a varying rate. So sometimes it pumps a lot, sometimes not very much. And depending on how much power is being drawn from the generator to operate other machinery. So if everything in the house is running, you don't pump as much, okay? The rate in gallons per minute at which the pump operates is recorded in 5-minute intervals for 1 hour. So how many gallons were pumped during that hour? Now, here's the thing. How many gallons were pumped? This is like our consumption problem. This is the how far we covered problem. This is the area problem. The thing is, we're given time and rate, but we're not given an equation to work with this. We do know this, that if we can integrate this pumping problem, I'll call it P of T, we can figure out how many gallons pumped, okay? And the other thing that we cannot do is we can't go through and just add all the different rates for the gallons, because then you've got to figure out like how much per minute and how many minutes, and it'll just be a really big, ginormous headache, okay? So we've got a couple problems staring at us. The good thing about this is that even though we don't have a specific function in here, we have a way to find the area under this curve, approximate the area very closely. Okay, wait for it. It's the trapezoid rule. It's coming back. Okay, why can I use this rule? I can use the trapezoid rule because I don't have a specific function, but I've got a rate that varies over time, and I've got specific data points that I can use. So what do we need from trapezoid rule? You may remember that the trapezoid rule is equal to h over 2 times y0, that's your first y value, plus 2 times y1, plus 2 times y2, 2y3, all the way up 2 times yn minus 1 plus yn. And the yn minus 1 and the yn are your final terms. Okay? H is equal to b minus a divided by the number of terms that we're using. So what do? Well, our A is going to be 0. Our B is going to be 60. And the number of terms then, we just need to count up how many times that we're looking at this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So n is 13. So we're going to have 60 minus 0 over 13 times y0. That's the 58 part. And this is going to be really long. And you'll have to write it out. There is no fast way on this, but there is a way. And so you're going to have to write it out so you can keep up with stuff. So this is going to be 58 plus, and then you're going to punch this into your calculator also. 2 times 60 plus 2 times 65 plus 2 times 64 plus, okay, you see what I'm going to do? 2 times 58, 2 times 57, times 55, times 55, times 59, all the way up to plus 2 times 60, plus 2 times 63, plus that very last term, 63, okay? So you add up all these guys. You just punch them into your calculator, pay very close attention to what you're doing, all right? Oh, we forgot to divide all this by 2, by the way. All that divided by 2. That's right there. Right there. Add all that up, multiply it by 60, divided by 13, divided by 2, and that's going to get us about how many gallons. Again, it's an approximation. It's not an exact answer, but I get somewhere around 3,582.5 when I punch it into my calculator, okay? So if you understand what you're doing, you don't have to show me every single step along the way, but you're going to have to punch it into your calculator. What do I need to see if you're in my class? I need to see this setup right here that shows me that you know how to use the trapezoid rule. All right, so how many gallons punched? Well, pumped 358.5 gallons.